Hi friends, good morning. Myself, Dr. T. Anand from Tamil Nadu Dr. J. Delta Fisheries University, Nagapattinam. So I am here to present the sludge volume prediction and analyzing the nutrient loads from stream farms of southern districts of Tamil Nadu, India. So the contents of the presentations are background, objectives, materials and methods, results and discussion, conclusion and references. So the background of the proposal, background of the research project. Development of shrimp farming in India, shrimp production, waste from shrimp culture, and characteristics of the sludge. During 1970s, the shrimp farming was developed in India, and during that time, the farmers were stocked with the seeds that are caught from wild. Later, the Phineas indica species that was formed in India has some problems, and again, the farmers switched to the Phineas monodon, that is black tiger shrimp. Again, during 1994, there was a setback for the industry. So the shrimp farmers were hit with a new virus called WSSP, and the WSSP became endemic everywhere, and it continued to affect the crop even till now. Many of the crop in India was getting failed because of WSSP. But later, during 2010 and 11, the Coastal Agriculture Authority of India has permitted the hatchery operators as well as the farmers to import the specific pathogen-free Vanamai rootstock and produce seeds, and the farmers can getting license from CAA and stock the seeds from the hatcheries that are producing Vanami seeds in their farms. So since from 2010, after getting the approval from the CAA, the farmers are doing Vanami farming. And you can observe after the introduction of Banami during 2010, so the shrimp production in India started gradually increasing, and it has got every time high in 2017 with 7 lakh metric tons, and again in 2019 almost 8 lakh metric tons. And because of Corona and other issues, the production was lowered in 2020, and again this year 2021 it went up to 9 lakh metric tons. So generally, in general, to produce 1 kg of shrimp, minimum 1.5 kg of feed is required. So the feed that is used in the shrimp culture industry consumed by the animal, and it is getting growth. And after consumption, the leftover feed, the waste from animal, and all the waste are getting into the pond, entering into the pond, and this is exchanged or letting by the farmers into the nearby creeks as a effluent. So that is why the Coastal Agriculture Authority has already given guidelines for treatment of wastewater that is discharged from the agriculture farms, hatcheries, feed mills. So the pH, suspended solids, so all for all like ammonia, COD, dissolved phosphate. So there is a standard. So what are all the standards? And the farmers has to adapt those things before treating, before letting the effluent in the farm. So the objectives of the present study is to predict the sludge volume from shrimp culture systems in the southern districts of Tamil Nadu, India, to analyze the nutrients in the shrimp farm waste sludge from southern districts of Tamil Nadu. So this is the study area wherein Mayoram, Nagapattinam, Tanjavur, Tiruvarur, Pudukkottai, Ramnad, up to Ramnad, from 156 shrimp ponds, the samples were collected, and yeah, again the same, and the coordinates mentioned here. Actually, in the farms, usually in shrimp farms, a number of aerators are used to oxidize the organic load as well as to bring the sludge as well as the fecal matter to the center of the pond. So in all the shrimp ponds, almost the sludge is settling in the center of the pond. So it is actually a BTech project. The project fellows are visited all the 156 ponds and measured the sludge directly. Maybe the sludge may be mostly in round shape, and maybe some farms it may differ based on the aerators they were provided. And the samples were collected from the farms for further analysis. The samples were dried in the laboratory for analysis of total organic nitrogen, carbon, and phosphorus. So apart from the samples collected from the farm, the data like the biomass harvested in the particular farm, and then the total number of HP of aerators used in the particular pond, and FCR, that is food conversion ratio, that is how much feed is used per kg of shrimp production, also collected from the farms. So all these three variables with the literally collected data on the sludge volume given as input in the linear regression model, and equation was derived from that, and this was given as an input for the web page development. So wherein we have developed a web page wherein this is the web link. And if a farmer want to calculate the sludge volume in his pond, he has to enter the A is biomass, and B is the HP of aeratus, and the C is the FCR. So the sludge volume will be coming in the bottom. So 107 cubic meter. So this is the sludge volume. So based on this, he can decide for the increasing the number of aerators and reducing the FCR for all, so that he can reduce the sludge volume. And the calculated sludge volume directly, the directly measured sludge volume from the forms, and the calculated from the web page developed or the equation derived, don't show much difference actually. So there was no much significant difference existed between the calculated value using the web page or else the derived formula as well as the directly measured sludge volume. So there was the Fisher F test showed that. And again, the biomass, aeratus, and FCR significantly influenced the sludge volume that was directly measured from the pond. And again, when these parameters are given as input in the principal component analysis, the principal component analysis showed that the sludge volume was highly influenced by the FCR, and then followed by the aeratus, then finally by the biomass. So based on the current study, FCR plays a crucial role in the sludge volume formation. And again, so actually based on the data collected from the pond, the sludge is divided into different categories like biomass categories. Like the B1 is from 1000 to 2000 kg, B2 is 2000 to 3000, then 3000 to 4000, 4000 to 5000 kg, and 5000 to 7000 kg. So if we observe the sludge volume, it is slightly increasing from 105 till 119 up to 5000 kg. But beyond that, there is a reduction in the sludge volume. But of course, there is differences in the number of ponds that is measured. And of course, sludge volume is increasing with increasing in the biomass also. And the nutrient content analysis showed that in different biomass groups, the total organic carbon is dominating in all the ponds, and followed by the total organic nitrogen and the phosphorus, except B1. In B1, after total organic carbon, total phosphorus is higher than the nitrogen. So this is about the nutrient content analysis. And based on the nutrient content CNP, the organic carbon that was measured directly from the ponds, the samples taken from the pond showed that 95 to 123 kg per ton of sludge is placing as the total organic carbon. And again, total nitrogen 50 to 80 kg per ton. And again, sedimentary phosphorus 30 to 90 kg per ton. So these are all the nutrient contents that is prevailing in the sludge. So the conclusions are the sludge volume showed increasing trend with increasing in the biomass harvested. Again, it is highly influenced by the FCR than the biomass. And again, the FCR was primarily influencing the sludge volume, followed by total HP of aeratus and biomass harvested. The shrimp pond waste sludge contains good amount of nutrients, so the farmers can reuse the sludge as a fertilizer for the next crop, or else they can grow in their farm some salt-tolerant varieties of plants. Though the CAA has laid down guidelines for releasing the effluents into the nearby aquatic ecosystems after proper treatment. But as of now, there was no policy framework or there was no guidelines for letting the sludge into the creeks. So these are all some solids actually. So what the farmers will do usually, after every crop, they will dry the pond and they will scrap the top layer or the central layer, and they'll put it down into outside into the aquatic ecosystems or any other nearby aquatic ecosystem. So there is no policy framework so far for draining or putting the sludge into the sludge waste into the solid waste into the nearby aquatic ecosystem. So the study is really an eye-opener to frame a policy for aquatic ecosystems or shrimp systems to exhibit or to drain the sludge waste into the nearby aquatic ecosystems in a safe manner after proper treatment. So though there are many industries that are harmful to the human beings and shrimp farming, the shrimp farming is in a growing stage now. So as of now, we have to implement a strict guideline so that in near future we can safeguard our aquatic ecosystem without any eutrophication and with all our natural ecosystems will be safeguarded if we have a proper policy framework. So this is about the presentation and some of the references. And thank you for your patience, friends. If you have any questions, please. Thank you.